overview of database systems. This is the first lesson you would be learning for the Database Management Systems module. This lesson provides you with broad coverage of the fundamentals of database management systems. Since you have already completed the Information Management module in Level 1, some of the content in this lesson will allow you to revise your knowledge of database systems. The content of this presentation would be formatted as per this color code. Take a moment to go through the color code. Learning outcomes. After completing this lesson, you will be able to define a database management system, identify types of actors, and compare a database management system against a traditional file-based system. When you visit a supermarket and purchase your grocery items, when you withdraw money from your savings account using your debit card, and when you buy your favorite book online, knowingly or unknowingly, you will be interacting with the database system. Databases touch all aspects of our lives. To store a huge amount of data such as product details, customer details, and order details, as well as to retrieve them as and when required, you need to interact with a database management system. For novices, it is important to learn the fundamentals of databases, and thus this will be a handy guide to support your software development process. What is a database? In general, a database is a collection of related data. It is a logically coherent collection of data with some inherent meaning. When you create a database for the university, you should store only related data. For example, you can store details of students, staff, degree programs offered, course modules, timetables, examinations. However, storage of air ticket prices or government election details like candidates and voter data may not be relevant for this scenario. Thus, a random assortment of data cannot be referred to as a database. A database represents some aspects of the real world, sometimes called the mini world or the universe of discourse. Changes to the mini world are reflected in the database. It is important to note that a database is designed, built, and populated with data for a specific purpose. That is, it has an intended group of users and some preconceived applications in which these users are interested. Therefore, as a formal definition, we can define a database as follows. A database is a persistent, logically coherent collection of inherently meaningful data relevant to some aspects of the real world. A database houses a collection of end-user data, that is, raw facts of interest to the end user, and metadata, that is, data about data. End-user data are raw facts that will be stored in the database by the end users. Metadata provides a description of the data characteristics and the set of relationships that link the data found within the database. A database can be of any size and varying complexity. Also, a database may be generated and maintained manually, or it may be computerized set of application programs or by a database management system. In the next section, you will learn about DBMS. What is a DBMS? Is a collection of programs that enable users to create and maintain a database. It has a set of programs to store and retrieve data in a database. Thus, we can define DBMS as a general purpose software system that facilitates the process of defining, constructing, and manipulating databases for various applications. The processes supported by a database management system are defining. A database involves specifying the database type, structure, and constraints for the data to be stored in the database. Constructing. The database is the process of storing the data itself on some storage medium that is controlled by the DBMS. Manipulating. A database includes such functions as querying the database to retrieve specific data, updating the database to reflect changes in the mini world, and generating reports from the data. To understand the above-mentioned process supported by a database management system, let us consider the following example. Consider a university database for maintaining information concerning students, courses, and grades in a university environment. Here, define, it can be file, records, data elements, data type for each data element. Construct, that is, store data in the appropriate files. Here, the records may be related between files. Then manipulating, it's about querying and updating. Your queries and updates must be specified correctly in a database system language like SQL before they can be processed. Database management system will help to protect the database. Protection includes system protection against hardware or software malfunction or crashes, and security protection against unauthorized or malicious access. It helps to control access to the database by various users. Furthermore, it facilitates maintaining databases over a long period. A typical large database may have a life cycle of many years. So the database management system must be able to maintain the database system by allowing the system to evolve as requirements change over time. Now you can do this activity. List 5 most popular database management systems in the industry. Identify hardware and software requirements for each type of database management system mentioned in one. We can call the databases and database management software together as a database system. We can call the database and the database management system software together as a database system. In the next section, we will learn about different types of database management system uses. Types of database management system actors. There are different types of DBMS actors, from DB administrators, designers to end users. Since you have already gone through them in your level 1, I will briefly go through the actors. Database administrators. They will be responsible for authorizing access to the database, coordinating and monitoring its use, and acquiring software and hardware resources as needed. Then we have database designers. They will be responsible to identify the data to be stored in the database. They will choose appropriate structures to represent and store data. They will communicate with all prospective database users to understand their requirements, develop a view of the database that meets the data and processing requirements for each group of users. And then we have system analysts and application programmers. System analysts determine the requirements of end users and develop specifications for CAN transactions that meet these requirements. Then application programmers implement these specifications as programs. Then they can test, debug, document, and maintain these CAN transactions. Then you will get workers behind the scene. Typically, they do not use the database for their purposes. They are DBMS system designers and implementers. Then you will get tool developers. Tools are optional packages that are usually purchased separately. They develop packages for database design, performance monitoring, natural language and graphical interfaces, prototyping, simulation, and test data generation. Then we get operators and maintenance personnel. They are system administration personnel who are responsible for the actual running and maintenance of the hardware and software environment for the database system. Finally, we get end users. End users access the database for querying, updating, and generating reports. There are various types of end users like casual end users, parametric end users, sophisticated end users, and standalone users. Difference between traditional file-based systems and DBMS. The traditional file-based approach is a mechanism wherein an organization allows all the files and folders which contain organization information to be maintained manually. Application programs are used to manage user data. In a file-based system, each application program handles its data and produces its output. In file-based system, each application or each department in an organization stores its own information. Drawbacks of using file systems to store data. Data redundancy and inconsistency. Some information may be duplicated for different reasons and will be available in different files. The data redundancy leads to higher storage and additional costs. In addition, it will lead to data inconsistency. For example, employee details will be available with finance department and HR department. If an employee has changed the home address and if it is only updated in HR department, then this leads to data inconsistency so that various copies of the same data may no longer be the same. Then we get difficulty in accessing data. In file-based approach, application programs are data dependent. That is, application program needs to be modified with the change in the physical representation or access technique of data. Thus, need to write a new program to carry out each new task. Data isolation. Since the data is stored in isolated manner in different files and folders, it takes time to determine the relationship between different data. Then we get integrity problems. In a file-based system, integrity constraints need to be handled in the program code. It would be hard to add new constraints or change existing ones as the program code needs to be modified. Atomicity of updates. An atomic transaction is indivisible. Either full set of operations in a transaction will happen or they will not occur at all. However, while executing the transaction, if it fails, then the database may be left in an inconsistent state with partial updates carried out. For example, transfer of funds from one account to another should be either complete or not happen at all. But we cannot guarantee this in traditional file-based systems. Concurrent access by multiple users. In multi-user systems, multiple users will concurrently access the database system. However, uncontrolled concurrent access can lead to inconsistencies. Therefore, the system should maintain a control mechanism to overcome this problem. But in a conventional file-based system, this kind of control is difficult to provide. For example, two people reading the same account balance and updating it at the same time could lead to inconsistency. Then we get security problems. The security of data is low in file-based system. The data maintained in flat files is easily accessible. In other words, all the users who log into the system get the access to all the data in the system. Database systems offer solutions to all the above problems. They can be considered as advantages of database systems. Even though there are many advantages of database systems, there may be certain situations where it is not possible to use a database management system. Do this activity to identify different situations where DBMS cannot be used. Summary. Now we have completed learning lesson 1. In this lesson, we discussed what is a database management system. A database is used to store related data. There are many different types of database actors other than the end users of a database system. In traditional file-based system, there are many problems, and as a solution to that, database management systems were introduced. In the lesson 2, we will learn more about databases and concepts. Before you go to the next lesson, complete the self-assessment quiz 1 to check what you have learned in the lesson 1.